Good afternoon. My name is Elena Puică. I'm from the Economic Informatics Doctoral School from the Bucharest University of Economic Studies, Bucharest, Romania. For the 39th TBIMA conference, I will present the regression predictive model in order to analyze the Internet of Things barriers in supply chain management. The agenda is starting firstly with an abstract. After that, I will present an introduction of the study. Then I will talk about the Internet of Things in supply chain management, the Internet of Things barriers in supply chain management, and I will present the regression predictive model, and I will end with a conclusion of the study. So the recent advances in information technology have led to significant changes in global production. And this study is focusing on barriers occurring from the Internet of Things as they lead to new ways of operating in supply chain. So modern supply chain have changed into more complex procurement chains and have become a significant source of competitive advantage. And identifying the source of the raw materials and maintaining the visibility of products in goods as they travel through the supply chain network has become increasingly difficult to verify. The current study is a preliminary approach to the development of a barrier production, analyzes model resulting from the use of IoT and existing in supply chain management. To achieve the goal, the study identified 8 other barriers for IoT users to prevent their implementation in supply chain. IoT barriers are further analyzed by addressing a SAP Analytics Cloud modeling, and the identification of the technological barriers underlying the supply chain management is a prerequisite to conduct the future research. The study is focusing on the analysis of the significant influence that the IoT have on the various aspects of supply chain management, the barriers encountered in implementing IoT technology in supply chain activities, such as consumer operation, product development, resource allocation, operations and optimization, revenue management, and network governance. IoT technology applied in supply chain management can help companies better observe activities that can be improved by identifying possible failures or to track and monitor products in real time, obtaining valuable information about consumers and sellers. The agreements and views of the supply chain management suggest that IoT will have a significant impact on many aspects of the procurement sector and the integration of resources, production operations, transactions, and products, leading to a much greater improvement in production and distribution efficiency of goods. This paper consists of 4 chapters and a conclusion. In the first chapter is presented the introduction of the paper, and the second chapter will be presented the IoT technologies in supply chain management, which is followed by the next chapter, which will be presented, in which will be presented the IoT barriers in supply chain management. The fourth part of the paper is a predictive regression model to analyze the IoT barriers and propose actions that could improve the level of those barriers. A conclusion is presented at the end. The Internet of Things in supply chain management. Trends show that the IoT technology have a significant impact on supply chain management. A third-fold increase in physical devices connected to the Internet will significantly change the way supply chain works. IoT technology makes it possible to improve solutions by intelligently connecting people, data, processes, and things through sensor and devices. Supply chains are part of a constantly changing environment, which is vulnerable to certain risk. Given that many supply chains extended over large geographical areas and cause vulnerability to more global risk. IoT technology reduces in the time between capturing data and making decisions, allowing supply chains to react in real time to change just that may occur, leading to levels of agility and representativeness that have not been experienced before. IoT technology also allows the design of new services from another perspective that is related to the end-to-end integration of supply chain. IT allows efficient management of achieving and maintaining the quality of the supply chain management, and due to the constant exchange of information, it is a crucial factor for quality management and control to be achieved in timely manner. These are areas where IT and supply chain management are currently coexisting successfully. For example, transparency and visibility of the SCM, proactive replenishment, predictive maintenance, reduction in asset loss, manufacturing flow management, product development and commercialization, risk management, operational efficiency, and improved fleet management. In supply chain management, the enterprises use the IoT application and devices described as interconnected devices or systems that can be monitored or controlled remotely via the internet, smart meters, smart thermostats, and smart lamps to optimize the energy consumption. Sensors, RFID, IP tags, or internet control cameras to improve customer service and monitor customer activities, providing a personalized shopping experience. Sensors for detecting movements or maintaining the movement of vehicles and products. RFID sensors or tags for the purpose of monitoring or automating production processes in logistic management and monitoring the movement of products. Monitoring devices that have built-in API functions have a degree of utility in several areas. They can report what is the power consumption, what is the performance of the equipment, and the state of the sensor. Moreover, they can perform actions when sending predefined commands. Applications that provide real-time solutions can use API features to report the current state of the system. While managers and developers have the option to call freely without having to physically access the devices, smart grids are suitable in identifying defects that may occur in production or performance by applying anomaly detection on data collected and those increased productivities. Consumers, data sources, and service providers are essential parts of IoT technology. Identify management and authentication methods applied to securely connect to the API affect both the time required to establish trust and degree of trust. The barriers in supply chain management. So regarding the implementation of IoT technology in supply chain management, there are significant barriers. These barriers include, for example, inefficient legislation and control, lack of skilled and trained workforce, or an inefficient performance framework and short-term corporate objectives. Poor technology capabilities resulted from limited availability of digital tools, as well as insufficient knowledge in digital and technology. The development of new technologies and innovations, lack of e-commerce infrastructure, qualified staff shortage, poor internet security are considered as the technological barriers. Supply chain management resists to change due to fear of innovation and work changes, profit loss, higher labor costs, and have no psychological guarantee about digitalization. Another major concern regarding the technological barriers is the data security. Skilled specialists that supervise the digital technologies when digitally transforming the supply chain management is an important factor to be considered because may be considered an obstacle as it's challenging to have a highly competent and technology skilled workforce. As the digitalization is continuously evolving, A shortage of digital skills and talents is also one of the factors that prevent digital transformation of supply chain management. Some of the barriers can be lack of the management commitment and support, an unclear organizational objective, employee empowerment and training, insufficient funds, poor corporate culture, mistrust among employees and partners, lack of education and training to employees and suppliers, poor information and communication technology infrastructure, and willingness to implement supply and management practices. Lack of integration, lack of collaboration, lack of responsiveness, lack of customer satisfaction. The supply chain barriers analyzed in these studies were costs are too high, the need to use connected devices or systems, do not know such devices or systems exist, lack of compatibility with other devices or systems, lack of skills to use devices or systems, and concerns about privacy of data protection and personal data. The regression predictive model applied in this study, it's a classification predictive model in order to discover what are exactly the barriers that prevent the implementation of IoT among supply chain management. By applying the regression predictive model, the following objectives are intended to be met. The first one is to find which barrier might potentially harm the supply chain management. The second one is to understand what are the main IoT barriers. The third one is to know from where to start to take action to ameliorate those barriers. And the last one is to encourage to take proactive actions to avoid encountering barriers in supply chain management. The training data set has three kept variables. The first one is reason for not using IoT. The second variable is to use of IoT in supply chain management. And the last variable is the percentage of IoT used in supply chain management. The target variable is a variable that has a specific role compared to the other variable available in the dataset, which represents the percentage of the reason why IoT is not used and signifies the event to be predicted. Several indicators were taken into account to identify the quality of the model. Prediction confidence, which measures how robust the predictive model is or its ability to reproduce the same prediction for our data. The role of the prediction confidence is to measure whether the predictive model can determine predictions with the same reliability when the new cases arise. If the new determined cases look like cases like the training data set, then confidence in prediction will be good. Prediction confidence should be as close as possible to 100%. The quality of the regression predictive model is measured by the root mean square error. It is a statistical indicator which measures the average of the square difference between values predicted by the predictive model and actual values of the target for all cases of the validation dataset. The smaller is this difference, the better the quality of the predictive model is. The model that was trained for this study has a mean square error equal with 1.53, and the prediction confidence indicator is 95.42%, which represents that it's a good model. The mean of the target is around 10.96 for the estimation and 12.56 for the validation dataset, and the standard deviation is around 12.71 for the estimation and 30.04 for the validation. We can say that the predictive model has a good quality, its robustness is above 95%, and thus it's also very close. The contribution of variables is another part of the ratio of a predictive regression model. The variables are displayed in descending order according to importance. The most taxpayers are those that best explain the target variable. The sum of all contributions variables is always equal to 100%. The variable reason for not using IoT has the largest contribution in the model, and the other variable it's using IoT and has a value of 12.38. The predicted values versus the actual values of the target variable. The green curve represents the perfect model, which shows no error and predicts exactly the correct opportunity value. The blue curve is the predictive model determined by SAP Analytics Cloud's Smart Predict. The dotted blue curves are the error mean and error max on the validation dataset. If the green and blue curves don't match at all, this means that the quality and the robustness of the predictive model are quite poor. If these two curves match closely, the predictive model is good and can be trusted to predict the value of the unknown target. Last case is when the two curves match a lot except in a few segments. This means that the predictive model is good but can be improved. The figure below describes how the values of variable positively or negatively influence the target variable. The model grouped values of the variable reason for not using IoT into categories with the same influence on the target. The more categories on top, the more positively influence the relationship between the target and variable. The longer is the bar length, the higher is the influence on the target or higher is the frequency on the value. Positive number influence positively the target. Negative numbers have negative variable that have negative impact on the target variable, and zero has no influence on the target variable. So it can be seen like no need to use those connected devices or system have a positive impact on target variable, and the concerns about the safety or health, lack of compatibility with other devices or service systems, concerns about the security, concerns about the privacy and data protection, and the cost too high influence negatively the target variable. The below table. In the below table are the categories that positively or negatively influence the target variable and are detailed. If the value is with minus, the contribution is negative, and if the value is it's with plus, the contribution is positive. So it can be seen for the reason for not using IT. We have three categories that influence negatively the model, and for the influencer usage of IoT, we have three categories that influence positively the model. If we look at the representation of the validation data, the category that has the lowest value of the target mean is concerns about safety or health and lack of compatibility with other devices or services systems. And the frequency is not that high compared with the other categories. If we look at the green dot, concerns about security, concerns about privacy and protection of personal data, didn't know such devices or systems exist, and lack of skills to use those devices or systems. These are the most frequent barriers determined by the model. The orange dot, the category cost too high, has the lowest frequency and the target mean around 30%. The category no need to use those connected devices or systems has a low frequency, but its target mean value is high. So knowing which are the influencers and how they influence the target provide variable. They provide information to discover new insights and give guidance to make decisions about the barriers that are the most frequent and how close are they from the target mean. For example, the category that contain the barriers, concerns about the security, concerns about the privacy and protection of personal data, didn't know such devices or systems exist, and lack of skills to use those devices or systems, represent 58.44. The category concerns about safety or health, lack of compatibility with other devices or systems is 88%. The category no need to use those connected devices or systems is 50.50. 58%. And the last frequent category is cost to hike with 9.09% of the validation data set. So, in conclusion, the regression predictive model provided insights for the objective proposed, the barriers that have the highest risk to potentially harm the supply chain management, and the main IoT barriers according to the model predictions are the lack of information about the IoT, the lack of high number of experts with the necessary skills in IoT, and the security concerns. The actions that could be taken to ameliorate and avoid encountering those barriers are to invest in training of a higher number of IoT specialists, to start informing more about the capabilities and what are the IoT solutions in supply chain management, and to take actions in developing high security protocols. In conclusion, from the above analysis can find that the application of IoT can provide a new operating environment for supply chains. It has a profound impact on the entire process of the supply chain management, on consumer behaviors and value propositions. Corporate behaviors and supply chain structure, product structure, and value composition. It is found that the most serious barrier is concerns about security and concerns about the privacy and protection of personal data. And the least critical barrier is cost to high. This does not mean that the barrier cost too high is not serious. It merely shows that the other barriers considered are more serious compared to others. This paper proposes a model to specifically discuss the barriers to supply chain management. It is proposed to exactly fit this study and may differ from the models proposed in previous literatures, hence adding some new insights and perspectives to the existing knowledge. In general, this study aims to inform the society regarding the barriers of technology implementation in supply chain management. Practically, the findings will be an eye-opener for business providers about the situation faced by supply chain management. The findings provide direction with appropriate proposal of actions to ameliorate the barriers and improving their performance level. The case study approach applied in this study will help providing better comprehension and insights on the digitalization of supply chain management. This study also serves as a guide to the future researchers to extend this study or the students with the same area of interest. Digital implementation in supply chain management is vital for business growth as it offers numerous benefits. Many supply chain management tend to delay its implementation in their operations. This paper extended the knowledge and digital supply chain management barriers. A regression predictive model was applied to get a better picture of these issues, and the significant barriers for the IoT and supply chain management around the European countries were highlighted. Thank you.